Hello and welcome to Mystery Science. Today's lesson is the rock cycle. That's right, science rocks. Hey! So, this is lesson 2 of our Key Stage 3 Earth and the Atmosphere topic. This is mostly aimed at the students at the college at which I work. They'll be working from workbooks or booklets, and I will be referring to that throughout the video, and there will certainly be certain tasks where I will be telling the students to pause and write stuff in their workbooks. If you don't have a workbook, or if you're not a student at the college and you want to participate, just write stuff down on a piece of paper. It can't hurt your learning. This will be suitable for anybody who's doing Key Stage 3 Science, or anybody who wants to update their knowledge on the rock cycle. So in this lesson we're going to be looking at the 3 different rock types. We're going to describe how each one is formed. We're going to explain their properties, and we're going to describe the rock cycle and link those 3 types of rock and how they all fit into the grand life of rocks. Right, we always start with do now questions. I've got 5 descriptions here, and I want you to tell me which part of the Earth's structure these are referring to. So pause the video and come back when you have answers. Welcome back. So, part 1. I am a dense, very hot, made mostly of solid iron and nickel. Well, we know that the Earth's core is made of iron and nickel. There's an inner core and an outer core, and the inner core is solid. So that's the inner core. Number 2, I'm iron and nickel too, but I'm liquid, hence the outer core. I'm really very thin and mostly silicon, oxygen and aluminium. Well, the thinnest part of the Earth's structure is the crust. I am a viscous semi-solid with convection currents circulating in me. As we know from the last lesson, we have magma underneath the Earth's crust in what's called the mantle. And this is rock that's very close to molten, and it's a semi-solid. It's nearly liquid, and it can flow. I just hang around on the outside, being cool. That is the atmosphere. Right, so there are 3 different types of rocks. Actually, if you Google rocks or search for rocks, you'll find thousands of classifications of rocks and different types of rocks, and rocks with different names, slightly different structures. But those categories all boil back up to 3 main categories, and we're going to discuss each of those in turn and how they're formed. These 3 categories of rock are igneous rocks, sedimentary rocks, and metamorphic rocks. Let's see what they're all about. So we start off with igneous rocks. Igneous rocks are formed very far underground in the mantle. So we've got magma, this rock that is viscous semi-solid, and it kind of flows around in a convection current. And we know from our last lesson that the Earth's crust will buckle and bend and break when these tectonic plates, the parts of the crust floating on this mantle, when it moves around. Sometimes this magma will escape, and this magma, when it escapes, will become rock. Before it becomes rock, it becomes lava. Lava is any part of the molten rock that's come out into the world. Now, when this lava cools down, we end up with a rock, and it's an igneous rock, and this is called an extrusive rock. It's lava that's been thrown out of a volcano or oozed out of a volcano, and it's hardened over a fairly short period of time and formed a rock. Extrusive rocks, though, are where magma is cooling down underneath the earth, so actually in the middle of the volcano. It's just kind of moved to the side, and it just kind of collects and it cools down inside the cone of the volcano, and this is an intrusive rock. And an example of this would be granite. So granite, the big kind of massive rocks that make up the tors on Dartmoor, whereas extrusive rocks are things like basalt and pumice stone, so like rocks that have cooled quite quickly, so they've just got kind of air bubbles in them, tend to be fairly brittle. One experiment that we do very early on in science, very early on in Key Stage 3 normally, is we try and separate salt from salt water, seawater, or we'll crush up some rock salt and we'll put that in water, and then we'll separate it using filtration and then evaporation. Now, the reason I bring this experiment up is because you may have noticed there's two different ways of getting the salt crystals out of the water. The first way is to boil the water away, and if you do that you end up with fine powder of salt crystals. It hasn't had time to kind of bind together and join together to make large salt crystals. Now, if you've ever made a crystal with a crystal growing set, or you've cooled your salt water on a windowsill, what will actually happen is the salt crystals, as the water evaporates, will actually come together and form big crystals. And the same thing happens with lava. If lava or magma cools really quickly, you get these small crystalline structures like pumice stones and basalt. But when the magma's got time to cool, so for example underneath the surface of the earth, you get massive crystals forming, and that's what happens with granite. Okay, our next category of rocks are sedimentary rocks. Now, sediment is a small layer of silt and mud and stones and rocks and pebbles, normally found at the bottom of a river. It's the kind of stuff that flows along, but where did it come from? Now, the beginning of the sedimentary rock is weathering. So you take an igneous rock, for example, granite, and over several decades of time, the weather will beat down on this rock and it will crack, and it forms pebbles and shale, and it will disintegrate into small pieces. And you can see this by going anywhere on the hillside, mountainside, anywhere where you've got massive deposits of rock like granite. You can see this on Dartmoor very often. You have these huge, great granite structures called tors, and around the kind of peaks you've got this exposed granite, and you will find lots of the granite has cracked or broken apart, and you'll find boulders, and then you'll have like smaller bits of rock all over the place. And you'll see this a lot on the seaside as well, wherever you have cliffs, both the weathering from the rain and the wind and the ice, and also the sea battering it from beneath will cause these things to break down. And this is called weathering. These small pieces of rock are then transported away, so they're normally caused by water. So the weathering, the rain will just kind of come down and smash these things to pieces over time, and then the water from the rain will then carry them away, often into rivers. So the rivers build up these layer of sediment, this kind of layer of small rocks and mud and silt, just kind of flowing along the bottom of the river. Eventually they kind of coalesce together, and they kind of as they're moving along, they get deposited. This is called deposition, and they just kind of sit where they are, and they eventually get buried by other bits of mud and silt and more sediment that's just flowing over the top. And so these things just kind of grow in the bottom of the river and then just kind of get too heavy and get buried. Once they're buried, you get a process called cementation, a bit like making cement. The pressure over time of these more and more layers building up on top and squeezing them down and constantly pushing them down, creating the pressure, cement it all together, and the minerals inside will actually squeeze together and just hold these rocks together. And examples of this would be sandstone or limestone. Now, the great thing about sedimentary rocks is they are literally a time capsule of the planet. If you go to the Jurassic Coast in Dorset, you can see some amazing cliff faces made of sedimentary rock, and you can literally see layers of time going down, and inside these layers just tell the story of a different era where different materials were on the ground and became sediments and got crushed together. Now, you can find fossils in sedimentary rocks because as the sediment gets pushed down, bits of or animals that have died, or even plants that have died, plant material that just dies off, lands inside the sediment, gets trapped and crushed in with the sediment. And that tells us a history of the world. So we find fossils in different layers and we can see the development of life. Most of the evidence of things like evolution are found in the sediments of rocks. You'll find much more basic creatures at the bottom layers of sedimentary structures, and then you get more advanced creatures as you go up, which shows you that these creatures have kind of developed over time. Now, you also get rocks with these lovely, beautiful ripple effects on them, and they feel really jagged, and you often wonder, well, how did this come about? And it's literally the ripple pattern of the water that was flowing over the sediment that kind of formed the rocks in the first place. And you get fragments of animals and bones and shells just kind of lodged into these rocks. So they tell a lovely, rich history of the planet. And so these things are only found in sedimentary rock. Okay, our final category of rocks are metamorphic rocks. Now, metamorphic rocks can be originally igneous rocks or sedimentary rocks. Now, these are rocks that are formed by the effects of pressure, a bit like sedimentary rocks, but also huge amounts of heat. You need both heat and pressure to be evident for these metamorphic rocks to form, and these are formed over a really long period of time. So when we look at the rock cycle, we'll see that what happens is you can get igneous rocks formed and then they end up getting buried somehow through weathering, and then they just kind of sink down and get pushed down with more and more pressure, and as we get closer and closer to the mantle, just the pure heat of the magma combines with the pressure to form these metamorphic rocks. So here's our cutaway of the Earth, all of the rocks above from the crust and the top layer of the mantle kind of push down and crush anything beneath it, combined with the heat from the magma underneath, that pressure from above, heat from below, really do a number on these rocks and change their composition and turn them into something new. And what will actually happen is, because you have them formed from these kind of layers of different things all pressing down, then most of the metamorphic rocks have these fantastic looking layers. All right, you've listened to me waffle on for a while. Time for you to do something now. I need you to fill in the gaps those of you from the college will find these in your workbook for task 1. The words that you need are in there. They are layers, stuck, granite, marble, fossils, limestone, crystals, pressure, magma and solid. If you can't remember some of these, you can't remember what I said, then go back and listen again. And that's one of the super benefits of me recording these as videos. Right, pause the video, fill in the gaps, and I shall see you shortly. All right, welcome back. So we have sedimentary rocks, for example, sandstone, limestone, and chalk. We've got igneous rocks, for example, basalt and granite. Metamorphic rocks, such as marble and slate. We saw that layering effect previously for metamorphic rocks, but marbling is another beautiful example of metamorphic rocks, and we use it decoratively in kitchens and marble columns and all kinds of cool stuff. So how were sedimentary rocks formed? Small pieces of sediment were stuck together by salt and pressure from rocks above. Igneous rocks are liquid rock formed by magma or lava, cooled down and turned back into a solid. So metamorphic rocks are the rocks were acted on by heat and pressure over a long period of time. Sedimentary rocks are usually soft and can contain fossils. They're also easily eroded, which means weathered and taken away. Igneous rocks contain crystals, very hard, and they never contain fossils because they're formed underground. Metamorphic rocks sometimes have tiny crystals, don't have any fossils, they're always hard, they're the hardest of the rocks, and sometimes arranged in layers. Right, task 2. This one is all down to you. What I want you to do is pause the video and go off on a search engine hunt. What you're going to do is have a look at this table. You've got 3 choices: igneous, sedimentary and metamorphic, and you have to assign these stones, types of rock, into their types: sandstone, marble, limestone, basalt, granite, mudstone, slate, conglomerate and obsidian. Some of those you'll be able to do already. Right, pause this video and off you go. Do a little Google search or use a Cozier to try and find out which one is which. Alright, so now we've got to the rock cycle itself, and this is a thing that takes place over thousands upon thousands of years. You've got our old friend the mantle, that kind of weird semi-solid layer of earth between the core and the crust. Now this layer of semi-molten, almost liquid rock is incredibly hot. Now as it forms a boundary with the crust, it forms a layer of molten rock, and this can end up being pushed up into weaknesses in the crust, and this is called magma. But when the magma leaks out even further through either cracks in the crust or through massive fissures like volcanoes, then it becomes lava. So magma and lava are slightly different because the lava is molten rock from the inside of the earth that's come to the outside. It's hit the atmosphere. That makes it lava. The magma is buried deep inside. So we have lava and magma. Now, when the magma crystallizes, or indeed when the lava crystallizes, we have igneous rocks, and the igneous rocks are either intrinsic or extrinsic, depending on whether it's formed by lava or magma. So this igneous rock builds up and builds up from these magma fissures. So the rock just kind of cools around the magma and gets pushed out as more rock is formed, and eventually can form hills and mountains, and these are different to the ones which are pushed together by the plates. So this slow uplift to the surface and through the surface means that now this igneous rock is exposed, and it's exposed both to the atmosphere and to the weather conditions, and so you can get rain and seawater and all these other weathering things battering these rocks, and that causes the weathering process where it breaks and forms small pieces, and then that's transported away, normally through rivers, and then deposited somewhere. And this is called sedimentation, where all of the deposited bits of rock particles and the salt crystals and all the other things just kind of deposit together and form a sediment, and that over time gets compacted as more and more layers get put on top of it. That compaction then leads to cementation, and that gives rise to sedimentary rock. Now, as that gets buried even further, then we end up with the sedimentary rock very close to the mantle, and so the heat from the magma in the mantle and the pressure of all the rocks above change that rock into a metamorphic rock. Metamorphosis means change, and again this can be slowly uplifted towards the surface, so we end up with these rocks at the surface. Similarly, sedimentary rock finds its way up to the surface. So this is the rock cycle. The metamorphic rock can also end up melting and becoming magma again, and so this magma is constant churning of this metamorphic rock, completely melting before it becomes solid again to become an igneous rock, and so this is why it's a rock cycle. Okay, over to you again now, and it's your turn to be really creative and design something cool. What I want you to do is create a storyboard to describe the life of Rocky the Rock. Now, Rocky the Rock can be a character, or it could just be, a rock that someone's named. Now, I want that journey to start Rocky off as magma or lava, and then his journey into cooling and becoming an igneous rock, and then talk about weathering, and then him forming into a sedimentary rock, and then being crushed towards the heat of the mantle to become a metamorphic rock. So create yourself a little story. It could something like this. You could make yourself a little comic strip. You could storyboard a film. You could storyboard an advert. You can do whatever you like. Once you've done that, it's time for the final progress check. So I want you to answer these questions in your workbook. All right, so hopefully now you've paused the video, you've done your progress check. If you haven't got a workbook, then pause the video after each question and see if you can get the answer right. Question 1. What are the 3 types of rock? Well, they are igneous, metamorphic, and sedimentary. What are the 2 conditions needed for a metamorphic rock to form? Remember, we need heat from the bottom and pressure from the top. Heat and pressure. Oh, why wouldn't you find any fossils in igneous rocks? Because they're formed from molten rock, which would ultimately destroy the fossils, but also they're made from rock deep down in the ground. The fossils tend to get trapped in the sedimentary rock, and the rock containing crystals is probably igneous rock, because this is formed by the hot magma or lava cooling either slowly over a long period of time to make big crystals or rapidly to make small crystals. What is molten rock that is inside the earth called? If it's inside the earth, remember, it is magma. If it's outside the earth, it is lava. Alright, that is the end of this lesson. Stay safe. I'll see you soon.